The value of the parameters for the stop-and-wait ARQ protocol are as given below. Bitrate of transmission channel equals to 1 Mbps. Propagation delay from sender to receiver equals 0.75 milliseconds. Time to process a frame equals 0.25 milliseconds. Number of bytes in information frame equals 1980. Number of bytes in acknowledgement frame equals 20. Number of overhead bytes in the information frame equals 20. Assume that there are no transmission errors. Then the transmission efficiency expressed in percentage of the stop-and-wait ARQ protocol for the above parameters is. So this is a question from computer networks regarding stop-and-wait protocol. If you don't understand stop-and-wait protocol, please refer to the video lectures for the same from computer networks section, and then you can come back and answer this. So here for the given stop-and-wait protocol, all these parameters have been given and they are asking us to calculate the efficiency. So we will see how to do that. So here I have given the entire messages which gets passed and we need to find out the efficiency. So initially the information packet needs to be transmitted, which is given by T transmission given here. After that the packet needs to travel from sender, this is receiver. From sender to receiver we need to add the propagation delay for the packet to travel through the medium from sender to receiver. At the receiver there will be some processing delay added, and after that there will be an acknowledgement frame which the sender will send back, which the receiver will send back to the sender. So the acknowledgement frame will also have a transmission time which are given as T transmission for ARQ, and the acknowledgement will also have to come back to the sender. So a propagation delay will be added there as well. This is the same. The time to travel through the channel is the same. Okay, so now we'll calculate this. T transmission delay is given by L by B, where L is the packet length and B is the bandwidth. So in the question they have given that the packet length for the information frame is 1980 bytes and there is an overhead byte of 20 in the same packet. So the total length of the packet is 1980 plus 20 bytes. So for byte we'll multiply by 8 to get the total bits in that packet, divided by bandwidth, that was 10 raised to 6 Mbps, megabits per second. That is 16,000 into 10 raised to minus 6, that is 16 milliseconds. Now we'll look at propagation delay. T propagation delay was given in the question, it was 0.75 milliseconds. The processing delay, T processing, is given here, it is 0.25 milliseconds. Now we look at transmission delay for the acknowledgement frame, which is T transmission for ARQ, that is 20 into 8 by 10 raised to 6. 20 byte is the length of the ARQ and 8 we multiply in order to convert it to bits, divided by 10 raised to 6 megabit per second, that is 0.16 milliseconds. Now let's look at efficiency. For efficiency, whatever this T transmission given here, only this part we are using to send the packet. The rest of the delays are just useless delays for sending to the receiver and all, etc. So for stop and wait, the efficiency is given by this T transmission divided by the total times taken for the packet to reach the receiver and then acknowledgement to come back. So efficiency will be T transmission divided by T transmission plus T propagation into 2 for this 2 plus T processing delay plus T time of acknowledgement. So that is given by 16 divided by 16 plus 0.75 into 2, which I have given twice here, 0.75 plus T processing delay plus T transmission of ARQ, that is 0.16, that is 16 by 17.91. They were asking us in percentages, so we will multiply it by 100, which is 89.33%. This was the answer.